Welcome to The Explainer. Today, we are diving deep into Meta's newest breakthrough in AI vision. It's called the Segment Anything Model 3, or SAM-3 for short. And trust me, it's a huge step forward in how machines see and understand our world. So let's just start with a really powerful idea. Imagine for a second, what if you could search an image, or even a live video, the same way you search for a word in a document? Just hit Control F, not for text, but for ideas. That's the core promise here. The ability to find every single example of a concept instantly. And this slide, it just nails the difference. Before, you might have had to point to one specific dog in a picture and tell the AI, hey, find this. But now you can just say the word dog, and the AI finds every single one in the image all at once. It's a massive leap from finding a single thing to finding an entire concept. Okay, so to really get why SAM-3 is such a game changer, we first need to understand the problem it was designed to fix. And that's the old limitation of AIs only being able to see one thing at a time. This was the big hurdle. You could, click on a car or draw a box around it, and the AI would neatly cut it out for you. But what if you wanted to find all the cars in a really busy street scene? Well, you were pretty much out of luck. The old models just couldn't generalize like that. They couldn't go from a single prompt to a whole category. So how did Meta crack this problem? Well, enter SAM-3. And look, this isn't just some small update. It brings a totally new capability to the table that really changes the game for computer vision. The secret sauce here is this new task they've created called Promptable Concept Segmentation, or PCS. Honestly, the best way to wrap your head around it is to think of it like a visual search engine. You give it one prompt, could be a word, a picture, whatever, and bam, it finds and perfectly outlines every single object that matches that idea in the whole scene. And what's really cool is how flexible this thing is. You can see here, you can just type in text, right? Yellow school bus. Or you can give it an example from the image itself, like circle one poppy to find all the other poppies. Or you can even do both. You could type players in white and then point to a specific one to really zero in on what you're looking for. It's just designed to be super intuitive. So you're probably wondering, how did Meta's researchers actually pull this off? It's not magic, I promise. It really all boils down to two major interconnected innovations in how they built and trained this model. So the first pillar is a brand new data set, and the scale is just almost unbelievable. It gives the model this vast library of concepts to learn from. And the second is a really clever redesign of the model's inner workings, which makes it much, much smarter at its job. Okay, first, let's just talk about the data. The new data set is called Segment Anything with Concepts, or SA-Co, and it's built on a library of over 4 million unique noun phrases. I mean, just think about that. That is an absolutely enormous vocabulary for an AI to learn from, covering a huge range of objects and ideas you see every day. And to be clear, this data set is massive. We're talking over 50 times larger than what researchers had before. It mixes high-quality, human-labeled images with, get this, 1.4 billion AI-generated masks. It's this wild combination of human quality and just sheer machine quantity that gives SAM-3 its incredible understanding of the visual world. Now, for the other key innovation, it's a clever little trick in the model's architecture called a presence token. Think of it this way. Before the AI wastes any energy trying to draw a box around, say, a cat, it first asks a simple yes or no question. Is there even a cat in this picture to begin with? This simple step, first confirming if something is there before trying to find where it is, dramatically improves accuracy and stops the AI from just making stuff up. All right, so that's all the theory, but the real question is, how does this new model actually hold up in the real world? Let's take a look at the results. And the results are frankly stunning. When you measure it on its main job, finding all instances of a concept, SAM-3 delivers a 2 times performance gain over the previous best model. Now, in the world of AI, that's not just an improvement, that is a massive leap forward. And you can really see that performance boost right here on this chart. The LVIS benchmark is a really tough test. It checks how well a model can find objects from a huge vocabulary. And SAM-3 shows a solid 22% improvement over the last state-of-the-art model. This really shows its power on complicated, messy, real-world images. This table really helps put everything in perspective.
So if you look at that top row, only SAM-3 has this powerful new concept segmentation ability. Its predecessor, SAM-2, can't do it. Other popular models can't do it. But, and this is an important but, look at the model size. At 3.4 gigabytes, it is way bigger than SAM-2 and especially a super fast model like YOLO. So while SAM-3 unlocks this incredible new power, those smaller, faster models are definitely still going to be essential for things that need to happen in real time.
But this might be the most impressive number of all. On a brand new benchmark that was designed to compare the AI directly against professional human annotators, SAM-3 is already performing at 88% of the human baseline. The gap between AI and human-level performance here is closing, and it is closing fast. Okay, so what does all this incredible power actually mean for the real world? Let's talk about how this kind of technology goes from being a research paper to something that could change entire industries. The potential applications are just enormous. In medical imaging, a doctor could ask to see every instance of a specific cell type. In e-commerce, a system could automatically tag every single red dress in a massive catalog. It just makes analyzing images at a huge scale faster and way more accurate, no matter what field you're in. But this is where things get really interesting, almost science fiction. When you combine SAM-3's visual smarts with the reasoning power of a large language model, you can create a SAM-3 agent. And this thing can understand incredibly complex requests, queries that need real spatial reasoning, like finding the dog closest to the camera that is not wearing a collar. That's a whole other level of understanding. And that leaves us with this final, fascinating question to chew on. We are literally watching an AI's perception of our world evolve. It's moving beyond just processing pixels into genuinely grasping the concepts and the ideas within them. This isn't just about better photo editing. It's about a deeper, more conceptual form of artificial sight. So the question is, what are we going to build when our machines truly start to see